percentage composition of chlorine, which is 63.86, divided by the relative molecular mass of chlorine, which is 35.45. For the calcium, you divide the percentage composition of calcium, which is 36.14, divided by the relative molecular mass of calcium, which is 40.08. Then the ratio of atom will now become 1.80 for chlorine and 0.902 for calcium. Dividing by the smallest answer and bringing it to the nearest whole integer, we have that to the nearest whole number, we have for chlorine to become 2 and the calcium to become 1. Therefore, the formula for the element is CaClO2. Example 7. A compound Y containing CH and O only was burnt in a stream of pure oxygen. The carbon 4 oxide and water produced were collected in pre-weighted absorption tube and carefully weighed. Readings obtained are initial mass of Y, which is equal to 20.63 mg. Mass of carbon 4 oxide produced is 57.94 mg. Mass of oxygen produced is equal to 11.85 mg. What is the empirical formula for the compound having that hydrogen relative molecular mass of hydrogen is 1, for carbon is 12, and for oxygen is 16. Solution. Compound Y contains CHO only. Mass of C in the sample is equal to 12 over 44 times 57.94 over 1, which gives us 15.80 mg. Mass of H in the sample is equal to 2 over 18 times 11.85 over 1, which will give us 1.32 milligram. Mass of oxygen in the sample is equal to 20.63 minus 15.8 minus 1.32, which will give us 3.51 milligrams. Elements within this compound are C carbon, H hydrogen, O oxygen. The ratio of atoms is equal to 15.8 over 12, which will give us 1.32. 1.32 over 1 will give us 1.32 for oxygen. If you divide the percentage composition of the element of oxygen, which is 1.32, divided by the relative molecular mass, which is 1. For oxygen, we divide the percentage composition of oxygen, which is 3.51, divided by relative molecular mass of oxygen, which is 16, which will give us 0.22. Dividing through by the smallest number and correct to the nearest whole number, we have that 1.33 divided by 0.22 will give us 6 for carbon. 1.32 divided by 0.22 will give us 6 for hydrogen. 0.022 divided by 0.22 will give us 1 for oxygen. Therefore, the empirical formula for the compound Y is C6H6O. Chapter 4. The laws of chemical combination. Law of conservation of matter. This law is basic in most calculations in chemistry. In its more original form, it states that matter can neither be created nor destroyed during a chemical reaction. The purpose of calculation, the law can be stated thus: in any chemical reaction, the total mass of initial substances is equal to the total mass of products of the reactions. Of course, we are aware that for the law to hold, the mass of reactions and the mass of products must be accurately obtained. If we heat calcium trioxocarbonate 4 and allow the carbon 4 oxide formed to escape, the mass of calcium oxide left will not be equal to the mass of the calcium trioxocarbonate 4. Now, looking at this equation, the mass of calcium trioxocarbonate being born will give calcium oxide and carbon 4 oxide. For the law to hold, the mass of calcium oxide and carbon 4 oxide are to be obtained. Example 1. A mixture of 12 grams of calcium and 64 grams of sulfur is heated until the reaction is complete and none of the reactants is left over. What is the mass of the compound carbon 2 of sulfide is formed? Solution. Mass of carbon used up is 12. Mass of sulfur used up is 64. By the law of conservation of mass of reactants equals to mass of product. Therefore, 12 plus 64 will give us 76. Example 2. 12.3 grams of iron 2 trioxosulfate 6 crystal were heated, gave 6.0 grams of anhydrous salt. If only its water of crystallization is lost as a result of heating, calculate the percentage mass of water of crystallization. Solution. Mass of iron 2 trioxosulfate 6 crystal is equal to 12.3 grams. Mass of the anhydrous salt is equal to 6.0 grams. Therefore, mass of water of crystallization is equal to 12.3 minus 6.0, which will give us 6.3 grams. Percentage of water of crystallization will now give us 6.3 divided by 12.3 times 100 over 1, which will give us 51.2%. Example 5. In an experiment to determine the proportion of oxygen to hydrogen in water molecule, 9.0 grams of oxides of iron were heated in a current of hydrogen. 6.5 grams of iron and 2.8 grams of water were formed. Using this data, determine the proportion of by which mass of oxygen to hydrogen in water. Solution. An oxide is usually a compound of an element and oxygen only. Therefore, 9.0 grams of oxide is made up of metal plus oxygen. Mass of metal after removal of oxygen is equal to 6.5 grams. Therefore, mass of oxygen is equal to 9.0 minus 6.5, which is equal to 2.5 grams. Mass of water formed is equal to 2.8 grams, giving water is made up of hydrogen and oxygen only. Mass of hydrogen is equal to mass of water minus mass of oxygen, which is equal to 2.8 minus 2.5, which will give us 0.3 grams. Therefore, proportion by mass of oxygen to hydrogen is equal to 2.8 is to 0.3. Law of constant composition. The law states that the same chemical compound contains the same element in the same proportion by mass. For example, 2.5 grams of one sample A of copper 2 oxide, when completely reduced, gave 2.02 grams of copper. 2.30 grams of another sample B of the same oxide prepared by a different method, when reduced, gave 1.68 grams of copper. Using this data, illustrate the law of constant composition.